So types are a little bit more details, right? So we go back to types and variables, and we have more information about them. Continuing what we covered in the last lecture. So we mentioned the different types we have, but we really didn't mention their sizes in a way. And then we discussed that basically a data type defines three things, if you remember from yesterday. How much memory you need for this variable, what are the valid operations that you can conduct in the variable, what is the third thing? You remember? So say the data type kind of defines three things. The memory, the valid operations, and exactly, the set of variables. Thanks so much. The range of values that this variable can get. And we said, for example, an integer will only get, 2 to the power 52 over 2 to the power 51, negative up to positive, but if you have a float, then it's different, you can get decimal floating point values itself. So these are the main three things you can get. Looking for the first one, which is how much memory you need for a variable, we said also int can be 16 or 32 implementation dependent. Well, but in most machines you guys will interact with, it's really 32. And we said short can really have 16 bits. Long can have 32 bits, at least. And we said unsigned, the advantage of unsigned is that it will only give you the full range for positive numbers. So it increases your range in the positive side at the expense of not being able to express negative numbers. Unsigned, which is the default thing, if we define an int, it will be signed. It gives you the negative 2 to the power b minus 1. B here is basically the 32 or 16 based on implementation dependent, but it says 32. So if we're talking about an int, so it's negative 2 to the power 31 minus 1 up to the power 31 minus 1. In fact, I should remove this minus 1 here. And start from 2 to the power negative 2 to the power 31 up to the power 31 minus 1. And then, well, later on, in later C editions, because that's something that is also a little bit counterintuitive. C does not have inherent types of two of the most commonly used things in Python. Boolean variables and strings. We don't have a type called string in C, and we don't have a type called bool or boolean in C. But then how can we use them? We will see later on. But for now, you can know that some of the later standards of C kind of specifies an additional type, and bool is one of them. And they try to extend the int to really have a 64-bit int. This is mainly came because most of our modern machines are really 64-bit wide, not 32-bit. So they wanted to support also integers as wide as the registers in your machine or unilateral. So this is a summary of the values and the sizes we can have. So we answered two of the three things we had in a type, which is the memory size as well as the range. And yesterday we already discussed the operations, and we'll continue it later on. So a short int, 16-bit, an int is 32, a long is 32, unsigned is 16, but it gives you, if you look here, for unsigned short int, it's 16, and short int is also 16. So I have exactly the same number of bits. But if you look into the range, this positive range is double this one. And the reason is I start from 0, not from the negative corresponding bit. Good? Then unsigned int is the same thing, and unsigned long is also the same. So this table is for reference. You're not really expected to know all these limits. And I will show you a way right now, if you really don't remember what is the limit or you want to use it in your program, you'll be able to use it. For example, you might end up having an ID of students in a class or in a course that you are building a database, but you want to make sure that the ID will never exceed the end limit, because otherwise your program will crash. There is a way to check against this limit without really remembering. Going into the floating point types, we have two. We have float and double. Float is the single precision, it's 32-bit, while double is 64-bit. In a digital design course, you will really learn how to represent floating point numbers. But the main theme here is you have what we call a sign, a mantissa, and the exponent. So the sign is whether it's positive or negative. The mantissa is really the value that you have before the 10 to the power something, and then the exponent is your exponent value. This is how we generally, IEEE represents floating points in a standard way. Well, now comes into what if I want really to know these numbers without memorizing them, can I use them in my program? In the C standard library, there's a header file called limits with h. It defines these constants. So it gives you something called int max, for example, and here I'm only showing some examples. if you need another limit, you can really get it also from the same file. So int max gives you the maximum value of an int, which is, for example, in our case will be this, well, 21474838647, right? So it will be this value. And you can try it in your own if you would like. And then, well, in addition to the max, you can also get the main values. For example, a short main, what is the minimum value? If you want something that is unsigned, so U long, U usually is represented as an unsigned. So unsigned long max gives you the maximum value of an unsigned long int variable. Okay? This is how to interpret these things. And then this is for the integer stuff. If you want it also for the floating point and double, you will find them in the float.h, also from the C standard library. So there is a variable called float dig, which gives you the decimal digits of a precision of a float. And double max also gives you the max value of the double. Again, play around with them a little bit. Here I have a snapshot of a very simple example that tries to bring the maximum value of a short, and this is going to be short max, right? In this example here, it turned out to be 32,767 because a short is a 16-bit. If you think about it, this will be 2 to the power 15 minus 1. Yeah, so another important thing related to types is what if you have immediate values or constant, like you have numbers? How does the compiler recognize these numbers? And yesterday there was something related to this for integer division. If you really divide 7 by 4, and your friend said, well, the TA said in the tutorial that in fact if I want this to be a float division or a double division, I can write 7 to be 7.0. How does the compiler recognize that 7.0 is really a float, while 7 is just an integer, right? So the way this is done is by convention. What I mean is that the programming language itself, as part of the standard, it tells you how to interpret constants. So if these are of type int, so simply they don't have any floating point operation. So any number that's just really a correct number, correct digit without any fraction is going to be an int by default. If you have something that, well, it's going to be interpreted as an int, but you want it to be represented as a long variable, so just to take more space, for example, there is a way to do it, which is assigning suffix to your number. So I can write 3988. If I wrote this only, it's going to be an int by the compiler. But if I'm using this number to add, for example, to another variable that is long, then I can say 3988L. In this case, I'm telling the compiler, please interpret my constant value here as a long int. Right? These are called suffixes. Okay. You can do the same thing for unsigned. So I can write 3988U. In this case, it's going to be an unsigned number. Good. What if I want to be unsigned long? Well, I can really add multiple suffixes. So I can say U and L. In this case, 3988 would be an unsigned long int. Yeah, well, you can. This question is completely equivalent to say, if you define a variable, should I write unsigned long int or should I write long unsigned int? Right? Because it's just the same thing. I have tried it in different compilers. Some would accept it, some would not. But I would say, aside from the rule, because it's not part of the standard, it's left for implementation dependency, the right programming convention for writing professional code, usually people put the signed representation at the very beginning. So if you want something to be unsigned, whether it's long or not, start by the unsigned or the signed one if you want to explicitly say it's signed, right? So I'm not saying it's wrong. You can if you would like. Some compilers are more strict than others because it's left for them to determine. But usually what I have seen in most professional code is people always start with the signed representation. So you say unsigned long int, and in this case, why is UL here, not LU in the previous example. When it goes to floating point constants, again, if you have any fraction, any decimal point, by default, compiler will know that this is a float or a double representation. Also, you can write numbers like this with an exponent in C. So I can write 3e-7, which is in fact can be read as 3 and then 10 to the power -7. That's also possible. Or I can write something like 24E2, where E is capital, here E is small, both are the same. So all of this will be represented as float constants or double constants in the combiner. Good? This makes sense? And you can also combine, in fact, fraction with the exponents. That's also, although in fact, this is not a very standard representation because the Montesca and the Ascii Standard is in fact a decimal number, because in fact I can take this point and raise the exponent. I can write it as 46e to the power negative 10 instead, right? But anyway, that's also valid in the combiner. Good. Usually how to represent numbers, especially floating points in machines, is covered towards the end of a digital design course. I hope if you are taking QDI now, by the end of the semester, you can really mix both, because there are problems that you can solve and really how to represent a number using bits into that way, right? And then if I want something, so all of this basically would be of type double, which is the wider type. But if I want them to be float, which is smaller one, well, I can also add the f to the number. So I can write something like, oh, I don't have an example here, but I can write something like 0.1f, for example. If I do this, 0.1 is going to be represented as a float instead of double. If I want it to be a long double, which takes even more space than the double, I can also write L, 0.1L. So in this case, it will be a long double. So by default, it's a double. If you add a suffix F, it will be float. If you add a suffix L, it will be long double, right? I know it might be a lot of theory, but just to lay down all the rules and then later on we'll play with them. And put in mind that we went back to the in-person setting, then these kind of tricks are in fact a good tool for questions like multiple choice questions in a midterm exam, for example, right? So, so make sure that you really understand these tricks pretty well. So going to the character type, a character is the smallest representation of any variable in C, and because it only takes 1 byte. So it's an 8-bit representation. Something that is very interesting is that characters in C are in fact interpreted as integers. Right? And we'll learn right now why this really makes sense, right? So because I have 8 bits, that means I have from the range of -128 to the range of 127. Why that's the case? Because you have 8 bits. If it's signed, then you will have -2 to the power 7 up to 2 to the power 7 minus 1. So it's -128 to 127. If you have unsigned character, then everything will go to the positive number. It will be 0 to the power 8 minus 1, which is 255. Yeah. So here, how do we really interpret those characters? So for example, you are writing in your keyboard and you and the machine is able to interpret that you really inserted a, for example, you work in a word processor, you write your name, I don't know, A, B, C, D. How does really the processor understands that what you hit in the keyboard is the letter A, then it writes it A in your software, right? We said before that your keyboard is nothing other than an input device. There is a driver, right? So whatever you input, some value is going to be written to a register, and then the CPU is going to read this value and then do something with it. The standard, well, these values has to be with convention. There must be a contract that tells the CPU, if I really hit the A letter, it's going to be interpreted as 0, 1, 0, 0, 0 something, and then once the CPU sees these values, it knows it's A. Because definitely, the CPU doesn't know what's A or B or C. It only understands zeros and ones, right? So you need some sort of encoding. And then, hence comes the Ascii standard, which is a way to encode all the valid characters, especially in the English language, in a binary way, right? So we have what we call the Ascii table, and this Ascii table gives us for each letter or digit or special character in your keyboard, what would be the actual bit representation for it, right? And then if I want to print something as a character using printf or read it from the console as scanf, I use a specifier %C, and we have seen this before. Now, we said that it's interesting that C deals with the character as an integer value. For example, if you, instead of using the specifier C, you use the D one, and you hit A in the keyboard, in fact, the value we get is the corresponding integer value of A, not A itself, right? Because remember, we said there is an encoding for A, which is a bit of zeros and ones, right, from the ASCII. These zeros and ones can be interpreted as decimal value, right? Then I can deal with them as they are normal integers. So let's have an example. If I print something like this, print f character specifier the S, then your program will give you S in the console. But if you do something like print and then D and S, you will not get S. You get something different. What is the value you will get? Well, the ASCII table tells us what is the value. For example, if I look for small s here, what is small s? S here. Well, this will be the value of, the way to interpret this is to say it's 114. So the way to read it is you really have two digits. So for example, the digits at the left of the table are the left digits of the decimal. So simply, if you have 8 bits, do you guys know what is hex representation? Do you see this already in 2DI or high school or not yet? You don't know how to represent hex and byte. So we know what is the binary number, the binary system, right? Zeros and ones, right? For example, if I tell you I have 0010, which is 2, right? 0100, that's 4, etc., etc. So there are also other number systems. So there is the octal system, there is the hex system. And the way you interpret these things here is that basically 11 is 1 digit and, well, here 5 is 1 digit. If you don't know what is x, I won't spend too much time with this right now. But the idea is, with this table, there is a representation of S, which is a value. For example, here it says F is 70, because if you look into capital F, it has 7 and it has 0, so it's 70, right? If you have, well, we were looking for S, so it will be 1, 1, and 5, so it's basically 115, right? Something of that sort. Right? So how to deassemble or decode the character into a decimal value. Right? And this is what you will get when you really print this statement. By the way, there are a lot of programs that try to, well, if I give you a string, for example, and tell you, please let me transform it from upper to lower, for example. Right? So you guys must have done this very simple exercise in Python. You get a file that is all lower characters, and then you want to transform it into all upper, for example, right? How to do it? Well, in fact, using the ASCII table, because you know that all the capital letters starting from A really start from the value 6, 5, while small a starts from the value 9, 7. So there is really a distance between them. It's a constant distance, constant difference between the capital and the small. If you read the number into a character as a decimal, you add this value into it, you will end up really with a small representation. You will have this exercise later on. I don't know if you have it in lab 1 or later now. Here it says that, well, character by default is 8 bits. But what about, for example, other languages than English that have more than already 26 characters? There has been a lot of calls that, in fact, the ASCII is not fair for other languages, it's only built for English. And English is more or less a language that has a smaller number of characters than many languages around the world. So you need more wider representation. So in that case, most programming languages came up with the standard of wide character, where you increase your character representation from 8 to 16, but even wide, 32, allows for more rich representation of different characters. The way to know what is your max and min your machine for the character, again, using the limits to h. You can have character min and character max. This machine, for example, my character min is negative 128, and my max is 127. Good. So similar to int and float and double, we have seen what is the type itself, and we have constants of this type, how to represent it. To have a constant character, you must have it between this single quotation, right? So you have something like a code X code, that means it's a character. If I have something like this, it means this is interpreted as a character, not as a decimal constant, right? Also, you can represent a character by its value in the ASCII representation. For example, this is equivalent to 65, and this is equivalent to 97, as we just said a minute ago, right? And we also have some special characters, especially for indentation, space, etc. So, and regular expressions deal a lot with this. For example, I have /n means it's a new line, /t means a tab, vertical tab, backspace, And these are also interpreted as characters. For example, multiple times we did a printf, and in the end of the printf we had a new line, right? This is a special character that is interpreted by the machine as a new line character. A lot of theory. So let's see how this also makes a difference in practice. We have different types, and we write a code that has multiple operations, multiple expressions. And one expression can include multiple types if it's a valid operation. So some of the operations are not valid, so you cannot make some values to some other values. Some others are valid if you do a proper casting. We know what's casting right now. And some others are proper by default. For example, if you have operands that have the type of character and short and int, something like this, for example. So you have your x as int, and you are really adding two characters together. In this case, the whole value of the expression will be transformed into the variable type. So a plus a will be transformed into integer. Well, how this can be an integer? We said the character is an integer that has an ASCII representation. If you look into the ASCII table, you will find that a is 65, small a is 97. You add them together, you get 169. X will be 169. You see what I mean? So here what happened is in fact what we call an automatic type conversion. An expression that have types of characters is converted into int, and this is valid and automatic because character is considered by the C compiler as a special type of int, right? The same thing applies, for example, if you have short, which is also a special type of int. If you have an example like this, well, I can have character x equal this. Well, what is going to happen right now? Let's think a little bit. A here is a constant character, but I'm adding it into an int, right? Which means you must really get the value of A. In this case, A is really a 97 plus 3, which is 100. This evaluates to an integer, so the whole expression evaluates to an integer. But then this integer can be automatically casted into a character because character is a smaller type. So x1 will get the value, the corresponding character of 100, right? Which I believe will be, well, A, B, C, D. So x1 will be D, most likely. And then character x2 equal x1 plus 1, again, you are adding a character and an int, which means the whole expression will be converted into an int. You get the int value, and then later on you convert it back to character because your variable is a character. Good? Now, if I'm bringing x1 and x2 as characters, I believe if I call the numbers correctly, this should be D and E. Because I'm breaking the corresponding character. Good? Okay. So I would say, okay, so I will just stop at this slide. Basically, well, this is the circles of scope. So int can be converted by default into long, if float into double, into long double. So any conversion here happens by default. Any conversion on the other side, when we discuss now, we'll discuss on Friday. Thanks for being with me in this good weather. Meet on Friday. Yeah. So I will write an announcement today.
Awesome.
Yeah.
Okay. And then the other thing,
Oh, hey.
I just had another question. Is there by chance another copy of the PowerPoint? Because the
Oh, I thought I cleaned this before posting. Yeah, I will clean it today as well. Yeah, thank you so much for letting me know. Yeah. Yeah, I will just leave it. Yeah. One thing to let you